Okay, welcome. Today we're going to study the law of cosines, and that's chapter 6.2 in your text, and that starts on page 437. Our objective today, so make sure you write this down in your notes along with the date, is students will be able to find the missing side or missing angle of an oblique triangle using the law of cosines. Now, we've already talked about the law of sines, and we found sides and angles using trig ratios. So our central question and this overall theme when solving triangles is essentially, when would I use the law of sines? When do I use the law of cosines? And when do I simply just use the trig ratios? So be thinking about that as we go through our lesson. Okay, remember during any time in the video, if you're falling behind, to pause the video and get your notes caught back up. And if you didn't quite understand something the first time, make sure you listen to it again. Sometimes it takes a couple times through to understand. And if there's some questions you're still struggling with, make sure you write them in your notes and we'll handle them in class. All right, let's go ahead and look at our formulas. Now you can see there are 6 formulas here for law of cosines. We have the standard form and alternative form. We're going to focus on our standard form. And if we look at these 3 formulas, we can see a pattern here. We know if it starts with A, and it's equal to the other 2 sides squared minus 2 times the other 2 sides times the cosine of angle A. If it starts with B, notice again, we're finding the cosine of angle B, so there's a connection. And here we're just squaring the other 2 sides, subtracting 2 times the other 2 sides. Same thing, pattern applies in the third one. So really, if we understand the pattern, we don't have to memorize 3, and that's what we're going to kind of focus on. So let's go ahead and let's just write down the first one. All right, let's look at our first example. This is a triangle that we are given 3 sides. So we have side A, side B, and side C. And we're going to find the 3 angles. All right, so focusing on the law of cosines, let's go ahead and start. And we always start with writing the formula down. Now I'm going to start by finding angle A. Now if I'm finding angle A, that means I'm going to start with the side across from it, little a. So I'm going to go A squared. Remember, that's equal to the other 2 sides. That would be B squared plus C squared minus 2 times the other 2 sides. That'd be A times B. Oop, back that up. Not A times B. Start that again. Apologize for that. The other 2 sides, which are BC, so that's minus 2 times BC, times the cosine of the side we started with. I'm sorry, the angle across from the side we started with, cosine of A. And once we have our formula down, it's simple substitution. I know what A is, it's 8 feet, so this would be 8 squared is equal to, B is 19 feet, 19 squared, plus C, which is 14 squared, minus 2 times the 2 sides B and C, so that's 19 times 14 times the cosine of the angle in front, which was little a, so we want the cosine of angle A, which is the one we're trying to find. And there we go. Now the next step is simplification. And we have to be careful when we simplify. I know 8 squared is 64. I know 19 squared plus 14 squared, which I've already figured out. You can use a calculator, but it will come out to 557 minus, now 2 times 19 times 14 is a negative 532. Again, that's a calculator problem, times the cosine of A. Now, one of the common mistakes, and make sure you write this down, is people will try to subtract these 2 numbers. Order of operations says we can't do that. 557 minus 532, that violates our order of operations. This is 532 times the cosine of A. So we have to multiply before we can subtract, and we don't know what the cosine of A is, so we can't do that. So, that being said, don't do that step. The next step is simply isolate cosine of A so we can solve for A. So I'm simply going to subtract 557 from both sides. That goes away, and we get a negative 493 is equal to negative 532 times the cosine of A. Divide both sides by negative 532. As we isolate A, we can see, and I'm going to do the room, I'm going to go over to here and say we have negative 493 divided by negative 532 equals to the cosine of A. I know I can still simplify that, but I'm going to use a calculator, so I'm going to do my last step. I'm going to take the arc cosine of both sides and then shove it in the calculator. So the arc cosine of negative 493 over negative 532 is equal to angle A. Now I've already pre-put that into Desmos, and remember when we're using our calculator to keep it in degrees because that's what we're working in, not radians. And we can see that our angle is about 22.075. I'm going to round to the nearest tenth and call it 22.1. So angle A is approximately 22.1 degrees. And now we have angle A. Now the directions call for solving the whole triangle. Now given that we have 22.1 degrees on all three sides, we can now jump over to the law of sines, which we previously learned, because we now have an angle and the side across from it and one other piece to solve for another angle. Now I'm going to go ahead and not do that piece since we already know how, and I'm going to move on to example 2 to illustrate the other law of cosines problem we might see. Okay, so example 2 looks like this. We want to find the remaining two angles inside of the triangle. So here we're given a triangle with not three sides, but two sides with an angle in between. Okay, we can't use the law of sines because we don't have the side opposite the angle, so we're stuck with the law of cosines. So we're going to figure it out the same way. I have to use my angle, so if I think about my formula, I'm going to work backwards on this one. This is the cosine of 150 degrees. That's the given angle. So I'm going to jump all the way over here and say I need the side across from it. That's the piece that's going to go in front. So this is going to be a squared. So a squared, a is the side we need, is equal to the other two sides squared and summed together, or added together. So that's 15 squared plus 10 squared, minus 2 times those same two sides, and just left myself enough room. Minus 2 times those two sides, 15 and 10, times the cosine of 115 degrees. Now before I get crazy simplifying, I'm going to realize I'm going to use my calculator on this. So what I'm going to do is I'm going to square both sides. I'm going to isolate A right here. A is equal to the square root of this entire expression. 15 squared plus 10 squared minus 2 times 15 times 10 times the cosine of 115 degrees. Now I'm going to enter this expression in my calculator, and again, make sure we're in degrees. Here it is. I can see that my angle is approximately 21.25 or 21.3. Now knowing this angle, like the previous problem, I now have a side and the angle across from it, so I can finish solving for my missing two angles using the law of sines. Okay, so we looked at 2 examples. If you still have questions, make sure you write them on the side, but go ahead and summarize the process for each one in your notes, and that'll help it stick in your brain a little better. Okay, I will talk to you in class.